Ladies and gentlemen, we're going to integrate x squared divided by the square root of 1 minus x squared using a trig substitution. And I know I want to try a trig substitution because we have this square root and a difference of two terms. So that's screaming trig sub. And it's pretty good because the first little bit is always the same. I call the square root thing g. You can call it anything you want. And then the next step is to rearrange this equation such that it looks like the equation for a right triangle, a squared plus b squared equals c squared. And then we'll draw the right triangle, and we make sure the hypotenuse is in the right spot. The x and the g are now on the sides, doesn't matter which side is which. And now we want to write theta in terms of x and theta in terms of g, using our friend SOHCAHTOA. So for x, we'll use cosine because x is in the adjacent. So cosine theta is x divided by 1. We'll put that up here. Now we want to know what g is. Well, we'll use sine because g is in the opposite. So sine theta is g divided by 1. And that means g is just basically sine theta. So now we need to know what dx is, right? So we'll take this equation, cos theta equals x, and we'll take the derivative and rearrange. So dx equals negative sine theta d theta. And at this point, we can substitute everything in. So our x squared is cosine theta squared. See that? And d theta, or dx, is negative sine theta d theta. So that's what we have here. And then our denominator is the square root thing, which we call g. But g is sine theta. So we have that here. And check this out. Sine theta cancels. So that's awesome. That's pretty nicely. And we're going to invoke a trig identity. Because if you don't know how to integrate cos 2 theta, it's like not really obvious. But we invoke this trig identity, cos 2 theta equals 2 cos squared theta minus 1. Things come pretty nicely. We're going to use this trig identity and solve for cos squared theta. And if we do that, we get rid of the square. So if we solve for cos squared theta, like imagine this in your mind. See if you can do this in your mind. We'll add 1 to both sides. So it's 2 cos theta plus 1. Then we'll divide by 2. So everything's divided by 2. That's what this 1/2 is. And then this cos 2 theta plus 1 is this cos squared here, because we have the 1/2 here. And then this negative is because there's a negative right here. So can you visualize that? Let me know if you like me going a couple steps in advance, or if you like absolutely every transposition. Sometimes I like to challenge us a little bit by doing a couple steps at a time. Okay, at any rate, this we can integrate no problem. I'll just kind of move things around a little bit. I'll yank out the negative 1/2. And now we've got to integrate these two terms, but due to the linearity of integrals, we can integrate each term separately. And that's what we'll do. So the integral of cos is sine, but we got to have a 1/2 here, because imagine you go the other way and take the derivative. The derivative of sine 2 theta, we have to do the chain rule. So we have this 1/2 here in there. Hope that's fine that you see that. And then the integral of 1, or d theta, is our friend theta, plus our friend the integration constant. And now we're basically done the integration, but we need to substitute back for what x is. And we know theta. So if x is cos theta, then if we take the arc cos, then theta is arc cos x. So that's good, but that's theta. But what about sine 2 theta? What is that? Well, we're going to invoke another trig identity. Surprise, surprise. And we'll use sine 2 theta, the one you kind of look on your equation sheet. Sine 2 theta is 2 sine theta cos theta. And we know what sine theta is. Sine theta is g. That's what we defined right here. Cos theta is x. So the sine 2 theta is g times x. And then our theta here is our arc cos. So yeah, that's pretty cool. And we're basically done. We'll substitute back what g is. G is, because we want to write everything in terms of x, right, is the square root of 1 minus x squared. And this is it in all its glory. Another one bites the dust. All right, on to the next integral.